some functions are in pieces, as we've seen this week, and they are called piecewise functions. One of the most famous piecewise functions is the absolute value function. We already have an idea of what this looks like. We've been doing a little bit of work already with it this week, but it's really split into two functions. So when x is greater than or equal to 0, the equation of our line is y equals x with a slope of positive 1. That's what makes this increasing look on the right side. When x values are less than 0, the equation that we're graphing is y equals negative x with a negative slope, which gets our shape to look like this on the other side. So we're going to look at this function as well as a few other examples. So first thing we want to look at, starting off, we see here that there's a separation at x equals 0. So I'm actually going to do like a dotted line through x equals 0 because this is dividing our graph into our two pieces. We can even write x equals 0 on top of that line, and then doing a little bit more labeling on the right side of this line. This is where x values are greater than or equal to 0. On the other side, this is where the x values are less than 0. Then what I'm going to do is I'm going to continue labeling by writing which equation goes on which side. So the equation on the right side, where x values are greater than or equal to 0, it just says f of x equals x, and another name for f of x, we could replace it with y. So I'm going to write the equation y equals x. Now for the other side, when x values are less than 0, our equation is y equals negative x. All right. Doesn't matter which side we start on. If we start on the right side here, if we think about this equation for the line y equals x, we have a slope of positive 1, or you can think about it as 1 over 1, thinking about rise over run, and the y-intercept is 0. So on the right side, we're going to think about our y-intercept here being at 0. We'll get our slope up 1 over 1, up 1 over 1. We'll keep doing that to get a few more points on our line. Now, if we were just graphing y equals x, the entire line would look something like this. But we're only going to graph the piece for x values that are greater than or equal to 0, so we're just going to be graphing the piece on the right-hand side. So I'm just going to connect that side. All right, over here on the other side, we can do some thinking about the line y equals negative x. This is a slope of negative 1, and this also has a y-intercept of 0 because there's nothing added on to the end. So if we think about this left-hand side, here's our y-intercept at 0. For negative slope, we're going to think about going up 1 over 1, again, but we're going to be going in the opposite direction, so that as we go from left to right, we see that it's going down. That's our negative slope. And again, we're just going to connect it up until this boundary line. If we were just graphing y equals negative x, we could graph it all the way down, but we're going to stop right there. And so we see it's actually the combination of these two separate lines that when they come together make our nice absolute value V shape. Okay, let's look at another example. So this time we have something different happening to the left and to the right of positive 5. And so this time 5 is going to be our boundary line. So I'm going to have you draw a vertical dotted line through x equals 5. And we'll do some labeling. So on the right side, that's where x values are greater than or equal to 5. On the left of the line is where the x values are less than 5. All right, so on the left side, our equation is f of x equals 3. We can replace f of x with y. Again, so we have y equals 3. On the right side, our equation is f of x equals x plus 2. You can replace that with y equals x plus 2. All right, so if we think about, let's think about our left side first. So if you think about the equation, or yeah, if you think about the graph of y equals 3, anytime we have y equals a number, that's going to be a horizontal line, and it's passing through that y value. So it's going to pass through the y value of 3. If we wanted to get a few more points on our line, every single, no matter what x value, the y value is going to be 3. So it's going to look something like this. But our line, it's going to stop right here at that boundary line. I'm actually going to put an arrow over here on that left side to show that that's going to continue forever going that direction, but it stops here at x equals 5 because when x is greater than or equal to 5, so all of these x values down here, we're actually graphing the equation y equals x plus 2. Let's write down a few characteristics about that line. Our slope is 1 and our y-intercept is 2. Okay, to help us graph this line, we're actually going to plot a few points on the wrong side. Do it with a pencil. You can go back and erase it later. So I'm going to plot the y-intercept at 2. Eventually I'm going to go back and erase that point, don't worry. For our slope of 1, up 1 over 1, up 1 over 1. I'm going to keep doing that, plotting as many points as I need to get some points to show up on the opposite side. Now we just want to focus on these points right here because they are on the right side of this boundary line that we drew. So I'm going to connect these points, and you can put an arrow at the end, and then go back, grab your eraser, and we're going to erase those points. We just needed those points to help us get what it's going to look like over here. So I would not recommend trying to draw this little piece of the line without starting on the opposite side. Always start at your y-intercept and then use your slope to move forward. All right, there's one final thing we need to do here. So we talked about this a little in our activity on Tuesday, but we need to make sure that our line still passes the vertical line test. And so that means if we were to draw a vertical line right here, the function cannot exist here and there. Otherwise, it will be two y values for the same x value. And so we are going to look at our symbols here. So notice how on the left side, the symbol was less than, not less than or equal to. So for x values that are strictly less than 5, it means it's not including 5. So on the graph that's on the left side, I'm going to put a big open circle right there on top of 5. So that's showing that it exists all the way up to something like 4.999999999. A lot of 9s, but not 5. So there's a hole. All right. Over here on this graph, this is x greater than or equal to 5. Since it could equal 5, we're going to put a big closed circle or closed hole right there to show that, yep, f of 5 will actually be this y value and not that one. Okay, below your graph, there are two additional questions. It says, use the graph to evaluate. The first one is f of negative 2. So what this means is that you're looking at the graph and you're figuring out what's the y value when x equals negative 2. So on your x-axis, find negative 2, and then go up to your line, and we can see the y value is 3. All right, let's look at our next one. F of 6 is asking us what is the x value? No, I'm sorry. What is the y value when x equals 6? So I'm going to find 6 on the x-axis and go up to the line, and that point is going to be right here going over to the y-axis. We see that's when y is equal to 8. Okay, let's take a look at this next example. So this time, the boundary line, if you look at this part first, that boundary line is going through x equals negative 3. All right, so we're always going to start by doing some labeling. So on the left side, that's where x values are less than -3. Left sounds like less, so you can think about that. Less than will go on the left side. On the right side is where we have our x values greater than or equal to 3. And I always like to do some color coding here. If you have some highlighters of your own, that just helps to separate this. All right, doing a little bit more labeling. So on the left side, our function is y equals 2x plus 1. Over here on the left side, our equation is y equals -x. Okay, so let's think about our equation here on the left side. So this is going to have a slope of 2, a y-intercept of 1. This is going to be a scenario like we had in the last problem, where we need to plot a few points on the wrong side that we'll go back and erase. So always start with your y-intercept. So we're going to do a y-intercept of 1. And then normally, if I was thinking about doing a slope of 2, I would go up 2 over 1, up 2 over 1. But I don't really need any more points on the wrong side. So instead, I'm going to follow that same pattern, which I can actually do that by going down 2 over 1 in the opposite direction. And I'm going to do that as many times until I have some points on the correct side. So there I have a few points right there. So I am only going to connect the points that are to the left of that boundary line. Take your eraser. We're going to go back and erase the others. And then for the other side, this is a slope of -1. It's got a y-intercept of 0. So always start with your y-intercept of 0. Slope of -1, up 1 over 1, and see that pattern there is going to give us the shape of our negative slope. And we can actually go ahead and connect this all the way down like that. All right, finally, let's think about the open circle and the closed circle. So the less than side, that's going to go with this part of the graph. Let me actually highlight this to match. Less than means it's not including -3, so we're going to put a big open circle there. The other piece of the graph was for x values greater than or equal to 3. It could equal 3, so we're going to put a big closed circle right there. All right, let's think about these two additional questions. So f of 4, so this means what is the y value when x equals -4? So if we find -4 and go straight down right here to this point, we see that y value is -7. All right, and the second piece, it's wanting to know the y value when x is 5. So we're going to find 5 on the x-axis and go down 3, 4, 5, 6. Hold on, I did not draw my line very good. I'm actually just going to continue with perfect points. That looks a little bit better. So when x is 5, it's 1, 2, 3, 4, 5. The y value is -5. Okay, so looking on the back side, in this next problem, our boundary line, again, is going to be x equals 0. So this is similar to the first problem that we did. So we're going to draw our dotted line. Right there on the left side, we have x values less than 0. On the right side, it's x greater than or equal to 0. On the left side, our equation is y equals -4. On the right side, our equation is y equals 3. All right, remember when it's y equals a number, it's a horizontal line that goes through that number. So on the left side, y equals -4. It's going to look like that. On the right side, this horizontal line is going to go through y equals 3. All right, don't forget about the open circle and the closed circle. So on the left side here, it's just less than, so we're going to do our big open circle for that piece. On the other side, it's greater than or equal to 0, so we can put a closed circle right there. Let's look at those two additional questions. F of -1 is asking what is the y value when x is -1, and we can see that it is -4. Okay, when x is equal to 0, so this is where that closed circle, open circle is really important. Because if you go down here, that's a big open hole. The graph does not exist there. So we want to look up here where it was the closed circle and it's going to be 3. Okay, this next one has a little bit more going on with it. So look, we have 3 functions. We're actually going to have 2 boundary lines. So there's going to be one boundary at -4. So let's go ahead and draw that. And we have another one at +1. So up until now, the graphs we've looked at have all been in 2 pieces. This next graph is actually in 3 pieces. Labeling is going to be very important here. So on the far left, we have x values less than -4. In the middle section here, this is where our x values are in between -4 and 1. The final section is where our x values are greater than or equal to 1. All right, let's go back and label our equations. So on the first section, it's going to be -x minus 5. I'm going to switch colors here so we can easily tell. The middle section, our equation is y equals 0. The last section, our equation is 1/2 x minus 3. Okay, well, let's just go from left to right. So thinking about this first line, it has a y-intercept of -5, slope of -1. So we are going to plot a few points on the wrong side. We'll go back and erase them. So we have our y-intercept at -5, slope of -1, we're going to go up 1 over 1, up 1 over 1, but making it so that our slope is negative. I'm going to keep doing that all the way to the edge of the graph. Now, the only ones I'm going to connect are the ones that are to the left of -4. So it's going to stop at the boundary line. Grab your eraser. We'll erase these points. Right now, let's think about that open circle, closed circle. So because it's less than or equal to, this is going to be a closed circle right there. Okay, for the middle section, y equals 0. It's a horizontal line that goes through the y value of 0. So it's going to be right here from here to there, right on top of the x-axis. This is less than, or this is just, yeah, x greater than -4, x less than 1. It does not say that it could be equal to it, so we're going to put a big open circle at each one of those. And then for our final side, this one has a y-intercept of -3, a slope of 1/2. So let's plot our y-intercept at -3. Our slope of 1/2 is going to go up 1 over 2, up 1 over 2. Let's do that to the edge of our graph. Now we're only going to connect it up until that boundary line. So just from here all the way out, I'm going to go back and erase that y-intercept. This one is greater than or equal to, so again, this is going to be that closed circle. Okay, using the graph, we are going to evaluate f of -3. So we want to know what's the y value when x is -3. Right here, x is -3, so we see that y value is 0. For the next one, what is the y value when x is 2? I'm going to go find x equals 2, go down to the point on the graph, and we see that y value is -2. All right, for this last question, we are going the other way around. We're given the graph, and we're going to go backwards. We're going to write the function using piecewise notation. First thing I like to do is draw the boundary line where the separation happens. So look to see where there's a difference between the two sides. So this is one piece, that's another piece, and that happens when x is equal to 2. So that means the right-hand side is when x is greater than 2. The left side is when x values are less than 2. Now this one, thinking about the open circle and the closed circle. So this one is kind of unique because the two pieces, they meet, they come together at the same y value. So at this point right here, it's a closed circle on top of an open circle, which makes it continuous, but we don't know which is which. And so if that's the case, you can put this or equal to line, you could put it on this one, not the other one. So think about, okay, the closed circle is over here, that's the open circle, and that works, that would be correct. Or you can put it on this one. What you don't want to do is put it on both, because if you put it on both, that's too We're not thinking about two closed circles, one on top of the other. So one of them has to be open. So I'm just going to keep it on this side. And then we're going to think about getting our equations. So the equation on the right side, this one is easier because it's just a horizontal line. It goes through the y value of 3. So that equation is just y equals 3. On the other side, we're going to identify our slope and our y-intercept. So our y-intercept is 1. It looks like our slope, if we do rise over run, 1 over 1, the slope is also 1. So we can write y equals 1x, or just y equals x, and then do plus 1 at the end for the y-intercept. All right, here's how we want to write that out. So we have f of x equals, we're going to do our brackets here, and we're just going to write x plus 1. We don't need to write the y equals part, so just x plus 1. Put a comma. That is for x values that are less than or equal to 2. And then for the other side, we'll just say f of x equals 3 when x values are greater than 2. So let's finish up with those additional questions using the graph. We are going to evaluate f of negative 5. In other words, what is y when x is negative 5? We're going to find negative 5 on the x-axis, go down on our graph. That point is right here. That y value is negative 4. All right, next we're finding f of 0, which is what is the y value when x equals 0. Right here, that's actually our y-intercept. The y value is 1. All right, and then finally f of 8. What is the y value when x equals 8? So here's 8. Go up to the graph, and that y value is 3.